Okay, so hello everyone. Just putting together a quick video tutorial, hopefully, on the midterm test that you guys should be able to use as a study guide or to identify maybe any areas you need to go back over in the notes. So the only two files I have is up the top. Horizontally, I've got the formula book you guys have, and then here vertically, I have the midterm test that we took. So, going to get stuck straight into it and see how we get on answering it. So, question 1, we had a communications tower with a cable attached as shown, and we were asked to calculate the angle theta. From looking at it, it's a right angle triangle, and that tells us that we're going to use SOHCAHTOA. So, silly old Harry caught a herring thinking of alcohol, or whatever way you're going to remember it. Once you spot that it's a SOHCAHTOA type question, it becomes pretty easy. You look at your angle theta, you can squiggle the two lines it touches. This is your opposite, this is your hypotenuse, and this is your adjacent. So I have information for my opposite and my adjacent. So if I'm trying to find that angle, I'm not going to use sine, I'm not going to use cos, I'm going to use tan. So, from my SOHCAHTOA, tan of theta is equal to opposite over adjacent. Tan theta is equal to opposite, which is 15, over adjacent, which is 30. Now, I'm trying to get theta by itself. So remember, when I bring tan over, something funny happens. It becomes tan inverse. So theta is equal to tan inverse 15 over 30. You can plug that straight into your calculator, and it's going to tell you that theta is equal to 26.57 meters. Oh wait, sorry. Theta is an angle, so my mistake. 26.57 degrees. So that's theta solved. So a lot of people went and used sine. You didn't have any hypotenuse information. You can't use sine. You could, in theory, solve for hypotenuse using Pythagoras' theorem and then use sine. You would get the same answer, but you don't need to. So that would have been, hopefully, a nice 3 marks for most of us. I'll leave it all there. So it's just knowing your SOHCAHTOA. It's one of the few things in the course you have to learn off. It's not given to you in the formula book. So learn it off and get used to using it. Anytime you're looking for an angle, you're required to bring the trig function over. When you bring a trig function over, it becomes inverse. So that's what happened here. And we've done plenty of examples of that. Okay, on to question number 2. So question number 2 tells us to calculate the area of the component. So the diagram shows a component that is part of a circular guard for a portable power tool. The component is shaded in grey. So it's only the grey part I'm going to try and calculate the area of. So let's go look at the formula book and see what help it gives us answering this question. So I'm looking for a formula for a section of a circle, or a segment of a circle. And it's there on page 2. So area of a sector of a circle is equal to half r squared times theta, where theta is expressed in radians. So let's go and solve. First of all, let's get this angle into radians. So 70 degrees in radians. And even if you don't memorize the formula, so it can be pi over 180, it's also given to you in the formula book. So to convert degrees to radians, multiply your angle by 2 pi and divide it by 360. Okay, so by 2 pi over 360 is how we convert degrees into radians. So 70 times 2 pi over 360, and that's taken completely out of the formula book. 2 pi over 360 is equal to 1.22 radians. Okay, now you might have also just said 70 times pi over 180, because that's the way we learned in class. That's fine, you're going to get the exact same answer anyway. So that would probably have got you a mark or two for this question. Now we're on to the area. So area, if we go back to the formula book, is a half r squared theta. So half of our radius squared times theta. Where theta is in radians. So pay careful attention to the formulas. Now, there's a slight trick to this question in that we're only looking for the area of the grey part. So if we use a radius of 90, we need to subtract the area of the 30 mil part. So first of all, I'm going to go and calculate the area of the total shape here outlined in red. So area total is equal to half. My radius is 90 squared times 1.22. And that will give me 0.5 times 90 squared by 1.22 is equal to 4,941 millimeter squared. Now I'm looking for the area of this smaller little blue segment. And how I find it, I call it my wedge, so area wedge. Same formula, half times radius squared. My radius is now 30 squared. My angle remains the same, so 1.22 radians is equal to 0.5 by 30 squared times 1.22 equals 549. 4941 minus 549, area of component is equal to 4392. It's area, so it's millimeters squared. So there's a few little knacks to that question. The first thing you need to do is check your formula booklet. It tells you the formula for area when you have the angle in radians. So that's a tip. It's a guide to go and convert your angle to radians. You can do that. It's in the formula book, 2 pi over 360 or pi over 180. The second catch was the spot that you're only looking for the area of the shaded component. So if you find the total area, which is outlined by this red bit, and you subtract the area of that smaller little blue segment, that gives you the area of the grey component. So hopefully nothing too complicated in there. If you need to check over your radians or segment of a circle, do. But that is probably as tricky as a question as you can be asked on that topic. Okay, now we're on to question number 3. So the image shows a steel wedge in the shape of a triangle. It's a 30 millimeter by a 50 millimeter right angle triangle. First thing we're asked to do is to calculate the area of the wedge. So the area is only this part shaded green. Okay, it's only that front face of the triangle that we want to calculate. So I can't colour in between the lines, but hopefully you get the idea. And it's not in the formula book from memory. It's one of the things you need to know. Don't think it's in there. Yeah, it's not in there, so you need to know it. The area of a triangle is equal to area is equal to half the base by the perpendicular height of the triangle. So in this case, it's equal to half times my base is 50 millimeter. My height is 30 millimeter. You can plug that straight into your calculator. 50 by 30.5. And you should get 750. Be careful, it's an area, so you need to include your unit, millimeter squared. So it's millimeter multiplied by millimeter, so it's millimeter squared. And that should hopefully have been a nice 2 marks. Now we're asked to find the volume of the wedge. So we know the area of that green bit. So the volume is just equal to area times width. So if we're saying the area is 750 millimeter squared, the width of the triangle is given to us over here. It was 5 mil. I've rubbed it out there by accident. I thought that was a highlighter. So this is simply 750 millimeter times 5 millimeter which is equal to 3,750. Again, be careful, there's a mark for this. We're dealing with volume. Millimeter squared multiplied by millimeter will give you millimeter cubed. So anytime you're dealing with volume, it's going to be cubed. And that was the answer to that one. Yes, so just highlight this, take it down and learn it. You're never given this, it's just expected that you know it. Area of the triangle is half the base by the perpendicular height. Yeah. And we've shown where that comes from in class before too. Okay, now this is a slightly trickier question. We're into logs. Okay, so I might have to move over to the right hand side to answer this one. It's a little bit tight for space there. But we're dealing with logs. So the first thing I would do anytime I'm dealing with logs, because they can be a wee bit tricky, is I would find the formula for them in my logbook or in my formula book, and I would jot them all down. And I can't remember what page they're on, maybe they're on page 1. Yeah. So they're on the first page of the logbook. Hopefully we can see them all there. Here. Log A B equals equal to log A plus log B. Log A over B is equal to log A minus log B, and log A x is equal to x log A. So I'm going to pause this for a moment just while I take them down on my page beside my answer. Okay, so I've just jotted down the formula there, and apologies, this is going to be a wee bit tight for room in this one. They don't leave you too much space, but we should have enough room to go and answer it. So we have an electronic engineering technician has been asked to determine the signal to noise ratio of a signal generator. 4 signal generators to be tested, and the results of the test can be represented by 2 log 3 plus log 4 is equal to log A plus 4 log 2. Solves the equation to find the value of A. So, like I said, I would approach this by writing down all the rules of logs up the top, and then seeing what terms we can simplify. Okay. So, I have a rule. Or sorry, at the start, I don't like the look of the 2 log 3 or the 4 log 8. They don't fit as nicely into the rules, but I'm going to try and simplify it then. So, anytime you have an equal sign, remember, it goes both ways. So I have x log A here, and that is the same as log A of x. So I'll keep it in my green pen. So my 2 log 3 becomes log 3 squared, which is equal to log 9. So that simplifies down to log 9 minus log 4 is equal to log A minus, I'm going to do the same for that 4 log 2. So 4 log 2 is equal to log 2 to the power of 4, which is equal to log 16. I'm going to scribble this over here. So log minus log of 16. And these should have been pluses. So plus and plus. So now I've got log A plus B. I can use my next rule. So log A plus B is equal to log A times B. So log of 9 plus log of 4, A plus B, is equal to log 9 times 4. 9 by 4 is the same as 36, so it's equal to log 36. So this log 9 plus log 4 here can be simplified to log 36. And I can do the same for this log A plus log 16. Although it's not going to give me anything, so I'm just going to have log A times 16. Okay, so if I write it all out, log 36 is equal to log of A plus log of 16. I'm still trying to get this A by itself. So we're going to bring this log over. That's going to give me log 36 minus log of 16 is equal to log of A. So when I have log A minus log B, that's the same as having log A over B. So log of 36, A minus log 16, the sign changes because I'm bringing it over the equal sign, is equal to log A over B. So log of 36 over 16 is equal to A over B. And so now I have log of 36 over 16 is equal to log A. I could simplify it. Log 36 divided by 16 is 2.25 equals log A. And all that happens now is the logs both cancel. So I've got log either side. Log of something is equal to log of something. Log of 2.25 is equal to log of A. The logs cancel and A is equal to 2.25. Yeah, so that was a wee bit messy. Hopefully I won't need as much room for the rest of them. Logs can be tricky, but I would always start by writing down all of the rules and then simplifying anything I can. Okay. And anytime you simplify it, normally, even if you can only simplify one term, you might get one of the 3 marks for the question. So it's worth having a go at it. And a bit of practice makes them relatively easy. Okay. Question 5. A helicopter takes off vertically from the ground and is stationary at point A. Calculate the height above the ground of the helicopter. So what you guys were being asked to do was to find this height here. I'm going to call it H. And if you spot it again, this is just another Sockatoa question. So silly old Harry, that doesn't look like a H, silly old Harry caught a herring thinking of alcohol or however else you're going to remember that. And you can fill in what you know. So you know your angle this time. H is the opposite you're looking for. Your hypotenuse is here, opposite your right angle. You don't know anything about it. And you know the value of your adjacent. So we're looking for opposite. Let's see which one we're going to use. Sine uses opposite and hypotenuse. So we don't know hypotenuse, we're not going to use it. Cos uses adjacent and hypotenuse. We don't know our hypotenuse, we're not going to use it. And we're left with tan again. So it won't always be tan, but always do the check. Tan theta is equal to opposite over adjacent. So tan of 22 degrees is equal to opposite, which we're looking for, O over adjacent 2100. So you're trying to get this opposite by itself. The opposite of being divided by 2100, when you bring it over the equal sign, it becomes the opposite. So a division becomes a multiplier. So 2100 times tan of 22 is equal to opposite. 2100 times the tan of 22, straight into your calculator. Opposite is equal to 848.46 meters. And that's that question solved. So it's important that you guys know and get very familiar and comfortable with using this SOHCAHTOA. We will go on and use a bit of it in mechanical principles as well to show how to resolve forces. So it will come back to us. Now we're on to question 6. The diagram shows a stamped angle plate. Calculate the length of dimension x. So we're being asked to find this dimension x. I know two angles here. I've got two sides. If you go up and have a look at your rules, excuse me, you've got a choice between sine rule and cosine rule, and hopefully you're screaming out, for this case we're going to use the sine rule. We know two angles, we know one of the sides. The sine rule makes this a pretty easy question to solve. So you can label it any way you like. Just remember, when the triangle is not right angled, how you label it, the angle takes a capital letter, doesn't matter what way you label it, but opposite of the angle you have the same letter lowercase. So A is here, B is here, and C is here. So for this example, I'm going to make this angle A, and instead of X I'm looking for A. I'm going to make this angle B, and then this is side B. Yeah. So the sine rule from the formula sheet tells us that A over sine A is equal to B over sine of B. Now you could manipulate this if you want to get to get A by itself already. I always find it's easier to plug everything in. So A over sine of A, sine of my angle A is 43 degrees, is equal to B, which is 160, over angle B, or sine of angle B, so sine 73. So again, you could bring this over already. If you're not great at transposition, A over sine 43 can stay the same. 160 over sine 73 in your calculator will give you an answer of 167.3. We'll say 0.31. And now it should hopefully be that little bit easier to transpose and not as scary looking. So the opposite of sine 43, of being divided by sine 43, is multiplying by it. So it comes over the equal sign. And now we have A equals 167.31 times sine 43, and you can plug that straight into your calculator. So 167.31 times sine 43, A is equal to 114.1 millimeters. So that's a little bit tricky. You just have to know the right rule, but if you've been practicing and doing the homeworks, the sine rule is a nice easy question. Don't let it scare you. It can look a bit scary. If you break it down, whenever you can at your calculator, it becomes that bit easy to rearrange and find whatever variable it is you're looking for. The other thing to point out is, if you're looking for an angle, you can say sine A over A is equal to sine B over B, and it just makes it that little bit easier to transpose again. But that's all given to you up here in your formula booklet as well. So just practice those if you need to. Okay, now we're on to question 7. The diagram shows a triangular ledge on a building. Calculate the length of side A. So in this one, it gives you a favour that it calls the side it's looking for A. So you've got another side B and another side C. When you only know one angle, which is this angle here, capital A, we're going to be dealing with the cosine rule. So let's go have a look at the cosine rule and see what it tells us to do. So A squared is equal to B squared plus C squared minus 2BC cosine A. So A squared, we're looking for A, so A squared is equal to B squared plus C squared minus 2BC cosine of A. And all you do is you plug it straight in and you take that bit of care. So A squared is equal to B is equal to 4, so B squared is 4 squared. C is equal to 6, C squared is 6 squared, minus 2 times B times C. Cosine A, and our angle A is 25 degrees. So simplify it as much as you can. Don't plug all of these into your calculator. That's likely where you might make a mistake. So 4 squared plus 6 squared is equal to 52 minus, so 2 times 4 is 8 times 6 is equal to 48. So minus 48 cosine 25. So 52 minus 48 cosine 25 is 43.6. Oh, sorry, 43.5. So A squared is equal to 52 minus 43.5 is equal to 8.5. So A squared is equal to 8.5. When you have squared, you want to get it by itself. The opposite of being squared is square rooting. So A is equal to square root 8.5. Square root of 8.5 is equal to 2.92 meters. And that's question 7 solved. So the question does you a favour by looking for side A. If you can find the right formula, it's just plugging it in and taking care. So try not to plug it into your calculator all in one go. It just increases the chances you're going to make a mistake. If you break it down into a little bit, bit by bit with your calculator, and it shows you know what you're doing, and hopefully it guides you onto the right way. Yeah, so question number 8. Nearly there. How many more questions we've got to go? Okay, so we're about halfway through. So let's go and have a look at question number 8. So calculate the surface area of a cone. We go and we find a formula for the surface area of a cone. Curved surface area of a cone is pi r L. So look at the shape, pi r L, and let's go and apply it to our question. Okay, so curved surface area was equal to pi times r times L. So in our case, we're not actually told what L is, and this is where some of the maths interlinks with each other. But what we do know is the height and the radius, so 3 and 2. And hopefully you guys are screaming out to me to use Pythagoras' theorem that L squared is equal to 3 squared plus 2 squared. L squared is equal to 13. L is equal to square root of 13, which is equal to 3.6. I'm going to say 3.61. And now I have L. This question is pretty easy to go and solve. So pi times r, my radius is 2, times L, which is 3.61. Pi times 2 times 3.61 is equal to 22.68 meter squared. So that's our curved surface area question solved. The knack there was being able to solve for L and spotting that that's a Pythagoras theorem problem. So trigonometry is very important for almost every topic. And it's something you need to get familiar with and be able to spot. Okay, now we have a solid spherical component, has a diameter of 0.06 and a mass of 0.35 kg. So draw it out. What do you have? You have a solid sphere, which is a circle, or a ball, diameter 0.06 meters, mass 0.35 kilograms. Calculate the volume of the spherical component. Volume of the sphere, we're told, is 4/3 times pi r cubed. So 4/3 times pi times r cubed. That's just taken straight out of the formula book. Is equal to, the only thing we have to spot is we don't have radius, we have diameter. Radius is half your diameter, so it's 0.03 meters for a radius. Just divided by 2. 4/3 times pi, they're constants, times 0.03 cubed. And you should be able to plug that straight in your calculator. 4/3 times pi times 0.03 equals 0.00011. You could say 1.1 by 10 to the power minus, is it, minus 4. Just leave it like this. Don't complicate things anything more than you need to. So the volume is 0.001 meters. And next thing we're asked to do is to calculate the density of the unknown material. So up in here, see what it tells us about density. So density, the symbol rho, is equal to mass over volume. So density is equal to mass over volume. We know the mass of the object, 0.35 all over 0.00011. Plug it in, equals 3181.8. Okay. And that formula was given us in the book. So on to question 10. Convert 60 degrees into radians. 60 times 2 pi over 360. I just memorized that from earlier. So 60 times 2 pi over 360 is equal to 1.047. Calculate the area of the base of the sector. So I'm only looking for the area of, I've used the wrong one again. I'm only looking for the area covered in yellow here. Quick check of the formula book. A half r squared theta, where theta is in radians. So this question helped you. It tells you to go and convert it into radians. So area is equal to a half r squared theta rad. It's equal to a half or squared is 2 squared. Theta radians 1.047. Plug it straight in your calculator, it's equal to 2.094. And it's area, so it's meters squared. Okay. Now we're asked to find the volume. So this is similar to that triangle question above. We know the area of this shape. The volume, we just need to multiply it by its length or its height. So because we know the area of that yellow shaded bit, when we multiply it by the height, we get the full volume. So volume is equal to 2.094 meters squared times 3 meters. Volume is equal to 6.282 meters squared by meter, and because we deal with volume, meters cubed. Okay, that's question 10 solved. Question 11, it tells you that you're dealing with a simultaneous equation question, so you nearly don't even need to read what it's about. So remember, you want one of the variables to be equal and opposite, and you can manipulate them to suit. So in here, I'm going to solve for x. Equation number 1, I've got 3x. Equation number 2, I've got x. I will multiply the bottom one by minus 3. So I need to multiply all of the bottom equation by minus 3 for this to work. 4y is equal to 3x minus 9. Y times minus 3 minus 3y equals x times minus 3 minus 3x minus 11 times minus 3. Be careful, minus by a minus gives you plus 33. So now if I add these equations together, 3x minus 3x are going to cancel. 4y plus minus 3y gives me y. And minus 9 plus 33, so y is equal to 24. I take this y value and I can plug it back into any of them. I'll go with equation number 2. So 24 is equal to x minus 11. I'm trying to get x by itself, so I'm going to bring this 11 over. That minus 11 will become positive when it's brought over to equals. It's equal to x. So 24 plus 11 is equal to x. 35 is equal to x. Now, it's always worth just checking your answer with another equation. So in here, I used equation number 2. So I'm going to check my solution using equation number 1. So 4 times y, 4 times 24 is equal to 3 times x. So 3 times 35 minus 9. So 4 times 24 is equal to 96. 3 times 35 is equal to 105. Minus 9. 96 is equal to 105 minus 9 is 96. So that equals, so I know I'm right. It's always worth doing that with a simultaneous equation question. It's just a nice way of knowing that you're right. Okay, I'm making okay progress here. Now we have an exponential looking question. Sorry, it's an indices question. So simplify the formula using one of the laws of indices. You have am to the power of n is equal to am times n. That's taken fresh out of the formula book. So n squared to the power of 3 is equal to n. 2 times 3 is equal to n to the power of 6. Should have been a nice, easy 2 marks for us, hopefully. Calculate the value of L, when n equals 4. So L is equal to n to the power 6. We know that from the work above. L is equal to 4 to the power 6. You put 4 to the power 6 into your calculator. 4096. Now we're on to question 13. The exponential log question. Okay. So, if you think back to your logs, generally what we're told is where we have ax is equal to y, that we can rewrite this as log of base a, y is equal to x. So we have e2x is equal to 6. We can rewrite this log, our a value here is e, so log e 6 is equal to 2x. Log base exponential is the same as ln, the natural log, so ln 6 is equal to 2x. I'm trying to solve for x by itself. X is equal to ln 6 over 2, and you can plug that straight in your calculator. Ln 6 over 2 equals 0.89. Okay, or you can round it up and you can say 0.9. That's 0.8958. So the clue here is it asks you to show evidence of the laws of logarithms. So this is one of the ones you're not given. It's something you need to know. It's the basis of all logs. A to the power of x is equal to y. Can just be rewritten. Log base a y is equal to x. And that's how you go and solve that one. So if you remember that, and then that log base e, you can put in your calculator as log base e or ln 6, you get the same answer. But you can rewrite log base e as ln 6 is just a number, is equal to 2x. When you rearrange this by itself, x multiplied by 2, you bring it over, opposites divide by 2, and you can go and solve that way. Okay, final question we had, state one of the conditions that must be met for a body to be in static equilibrium. So we've only touched on this a wee bit, that's why it was only worth 1 mark. It's leading into the mechanics we're going to study. But really, what we're looking for is all forces must equal 0. The object must not move. Objects that stay still. No twisting. So any one of those points would have been fine and it would have got the marks. So that's the full test done. Takes me a wee bit longer just because I have to explain every step I'm doing, but hopefully that gives you guys some sort of revision to help you understand the test questions and maybe identify any issues you have. Every topic on that test we've covered to date. All of the notes or everything you need is on Teams. The formula book is on Teams. The notes for every topic are on Teams. There's blended learning consortium guides there as well to help you, and the homeworks as well are all past questions. So every question that was on that test would have been covered as a homework at some point. So hopefully if you've been doing the homeworks you've done very well, and hopefully this video was useful to you. Okay, thank you, and I'll talk to you guys again.